Good morning to everybody. I am Sara Zollini from University of L'Aquila, and today I'm going to introduce you a geomatic multiscale approach for the conservation of archaeological sites. In particular, we are going to study the Alba Fucens archaeological site. So at first we are going to do a brief introduction of the location of this area, then why we decided to study archaeological sites with geomatic techniques. Then we are going to see materials and methods used for this research, and in the end the resultant discussions and the conclusions. So the archaeological site of Alba Fucens was built in 303 before Christ, and it is the largest archaeological area of the Apennines. It is located in a small village next to L'Aquila, that is in the center of Italy. So here you can see the location and how the archaeological site is composed. The purpose of the work started from the knowledge and the conservation of an archaeological site, because knowledge and conservation is really important, but it is often a challenging task because of its properties like extension, environmental location and anthropogenetic factors. So it's important the restoration and the conservation of these areas, for this study we need to take into account past intervention, stone characteristics, the environment, monument architectonic features and so on. So it's important to create a methodology in order to have the registration, the documentation and evaluation of the weathering forms, which are in general time-consuming activities, and it's essential to understand in archaeological sites the decay forms and the mechanism of decay. So it is also important to evaluate detailed architectural information of the buried and excavated amphitheater structures. So the main purpose is the extraction of architectonic and weathering information useful for a better fruition and conservation of archaeological sites. So about materials and methods, we are going to use a multiscale geomatic approach, which means that we used satellite remote sensing and UAV photogrammetry images, because they can allow the study both at small and a large scale. So at first we used the satellite very high resolution Worldview 2 multispectral images, which are composed by 8 bands and a panchromatic band, and it is very high resolution because the resolution is 0.48 meters in the panchromatic and 2 meters in multispectral. About the methodology, we performed, as all the satellite images, a pre-processing, which consists in orthorectification, georeferencing, resampling and past sharpening. About orthorectification and georeferencing, they are useful for geometric corrections, we make NRTK GNSS measurements to take 19 ground control points, GCPs, and 8 checkpoints. After that, we perform the resampling in order to assign geometric information, and we used the nearest neighbor technique. In the end, we performed past sharpening. The past sharpening is a fusion method, which means merge the two images in order to obtain a new image with the geometric resolution of panchromatic and radiometric resolution of multispectral. Then we make the processing. That means applying filters and algorithms in order to enhance some characteristics that we want to study. And the first one is the high-pass filter, which is a filter which maintains only the high frequencies of the signal, so it highlights the differences in intensity between the pixels and the background. Then we apply the principal component analysis, the PCA, which is often used as a compression data compression method, and we took only the bands with the highest variance, and they are taken into account in order to reduce the complexity of the work. Then we apply the NDVI, which is a combination between red and near-infrared band, and it is often used to detect and study vegetation, but it's also used to investigate buried structures in archaeological sites. In the end, we perform the classification in order to create a thematic map, because with the classification, pixels with similar spectral signature are grouped into chosen classes. Then, with UAV photogrammetry, here you can see the instruments we used for the UAV photogrammetry. We used a multi-rotor Flynovex UAV and Sony Alpha 6000, whose geometric characteristics are reported here, technical specification. For the methodology, we started from a flight planning, and then images acquisition, and then we insert the GCPs, then the alignment, then we obtained the dense cloud and the mesh and the texture of the 3D model, and in the end we obtained the digital elevation model, the DEM, and the results, the orthophotos. About the flight planning and images acquisition, here you can see the path that we follow to take the images, in which we applied an overlap and a side lap respectively of 80% and 60%. And we took in total 68 pictures with a ground resolution of about 1 centimeter. So here you can see the results that we obtained by satellite images, World View 2 very high resolution. Here we apply the NDVI, so you can see that there is the presence of buried structures. Instead, with the PCA analysis, we applied the PCA on all the bands separately, but the more interesting was the coastal band, because it shows some traces in Colle Pettorino area. Then, with the high-pass filter, the high-pass filter is an excellent method to identify all the paths in the scene, and in general it highlights the morphological variation of the terrain. So this application is very useful to assess and monitor the state of degradation of the site in terms of soil erosion, and in the evaluation and construction of suitable walkways. With the classification we could create a thematic map, and combined with the NDVI it allows to distinguish between high and low vegetation. So in this way it will be possible to assess the fire risks of the area. With the UAV photogrammetry, here you can see the 3D model and the DEM we obtained of the amphitheater, which show different orders of cave, IMA, Media and Summa. And they are really visible and detectable only on the right side of the north-oriented Porta Triumphalis. Instead, in the other pictures, you can see the reconstruction of the whole structure, the amphitheater, with the definition of the architectonic elements and in particular their dimensions. So, the arena surface was about 1,680 square meters, with the major and the minor axis of about respectively 62 and 34 meters. 6,000 persons is the estimated maximum capacity of this amphitheater. Moreover, with UAV photogrammetry, we could see the different heights of the amphitheater using the DEM. So we draw some profiles, And as you can see, the heights are really different between them, maybe because of an unfinished deconstruction or the collapse over centuries. In the end, we studied the weathering forms that you can see here in the table, but the most significant was the humidity of the podium areas, and it is significant because of the rainwater seepage coming from the buried upper cave. So, going to the conclusions, we applied a multiscale approach for the knowledge and conservation of a wide archaeological site. Alba Fucens area was taken into account, and it was studied with very high resolution satellite images and UAV photogrammetry. About the satellite images, we can say that NDVI and PCA allow to see several buried structures, probable several buried structures. With the high-pass filter, we could see morphological variations of the terrain and the walk path present in the areas. And then with the NDVI and the classification method, we could classify high and low vegetation. About the 3D model and the dam obtained from UAV photogrammetry, we could analyze architectonic elements and their dimensions. And by the orthophotos, the weathering forms and the decay forms were defined. So we can conclude that for archaeological sites it's really important to study them at small and large scale, and it is a powerful tool to reduce the risks linked to the identified elements in order to program suitable intervention plans for the territory management and the promotion of cultural heritage. Thank you.